Welcome to Technically You. Today we're going microscopic, and we mean really microscopic. We're diving into the powerful world of nanotechnology, where science meets the atomic scale to solve some of the biggest challenges on Earth.
Yep, this is the tech that's smaller than your DNA but could revolutionize medicine, energy, manufacturing, and even electronics. Let's break it down: what it is, how it works, and why it's not just science fiction anymore.
So let's start with a basic definition. Nanotechnology refers to the science, engineering, and application of materials and devices at the nanoscale, which is about 1 to 100 nanometers.
To put that in perspective, a human hair is about 80,000 nanometers wide. We're talking atoms and molecules here. It's like designing at the Lego level of the universe.
Right. And at that scale, materials behave differently. Quantum effects kick in, surfaces become more reactive, and we get access to properties like extreme strength, conductivity, or reactivity. So, how does nanotechnology works?
There are two main approaches: top down, where you miniaturize existing structures, and bottom up, where you build from atoms or molecules upward, almost like 3D printing at the atomic level.
Tools like scanning tunneling microscopes, STM, or atomic force microscopes, AFM, let researchers see and move individual atoms. That's wild.
Let's talk impact. Here are just a few places nanotech is making waves. 1. Medicine. Targeted drug delivery using nanoshells or nanoparticles that release medicine only at the diseased site. Nanosensors that detect cancer cells or viruses early. Nanorobots, still in development, that might one day perform internal repairs or clear plaque from arteries. 2. Electronics. Faster, smaller, and more powerful transistors in CPUs and memory chips. Quantum dots for sharper, more energy-efficient display technology. 3. Energy. Nanomaterials in solar panels to improve energy conversion. Nano-enhanced batteries with faster charging and longer life cycles. Hydrogen storage using carbon nanotubes. 4. Environment. Nanofilters to purify water. Carbon nanotube membranes that can remove heavy metals or toxins. Nanocoatings that break down pollutants or reduce energy usage in buildings.
Here's a quick run through on the types of nanomaterials. Fullerenes, spherical carbon structures like buckyballs. Carbon nanotubes, CNTs, super strong and lightweight, great for structural use. Graphene, one atom thick carbon layer, ultra conductive and flexible. Nanowires, useful for sensors and semiconductors. And quantum dots, emit precise wavelengths for use in imaging and electronics.
So I guess I'll cover the benefits and risk associated with nanotechnology. Well, pros: you get more efficient, smaller, lighter, and smarter everything. And cons: some nanoparticles can be toxic or biologically active in unpredictable ways.
That's why nanotoxicology is a growing field, studying how these materials interact with the human body and the environment.
Here are some areas where nanotech is already being used: COVID-19 vaccine delivery systems, stain-resistant clothing, scratch-proof eyeglasses, self-cleaning surfaces, tennis balls that last longer, and even nanoparticle-infused sunscreen.
Yeah, that's sunscreen you can't even see, but blocks UV rays better than traditional lotions.
Looking forward, here is the future of nanotech: programmable matter, medical nanosurgery, smart fabrics that change with your environment, and even space elevators made with carbon nanotubes. Maybe.
But we've also got to tread carefully. Nanotech will need ethical frameworks, clear regulations, and continued safety testing.
So from revolutionizing healthcare to powering the next generation of electronics, nanotechnology is proving that sometimes the smallest things make the biggest difference.
This is tech that could redefine the future on a molecular level. Thanks for listening to Technical EU. And remember, no idea is too small when it's backed by big science. And as always, stay informed and stay curious.